Good morning, ladies and gentlemen. I'm Jack Daly, Director of the Smithsonian's National Air and Space Museum, and it's my pleasure to welcome you to a special presentation by the crew of STS-135. The crew flew NASA's final space shuttle mission on Atlantis and will be sharing insights about their history-making flight. Today's program is a collaborative one presented by the museum in cooperation with the National Aeronautics and Space Administration. The gallery we are gathered in, Moving Beyond Earth, highlights the era of the Space Shuttle and the International Space Station. This museum is renowned for its collection of historic spacecraft, related artifacts, and a reputation we would not enjoy without the support of NASA. For decades, our close relationship with the agency has allowed us to acquire, preserve, and present space vehicles, equipment, spacesuits, and other artifacts. There are several space-related galleries in this building, tracing the history of human spaceflight back to the Mercury program. And at the Udvar-Hazy Center, an entire wing of the building, the James S. McDonald Space Hangar, houses space icons. The Smithsonian partnership with NASA will achieve another milestone with the arrival of the Space Shuttle Discovery next year. Let me take this opportunity to publicly thank NASA for selecting the National Air and Space Museum as the new home for this treasure. Discovery will be on view at the Stephen F. Udvar-Hazy Center, and when it arrives, we will invite the public to participate in the welcoming ceremonies. People often ask us what spaceflight is really like, and today we will find out. When Atlantis arrived after its mission, its commander stated how happy he was that the orbiter's next mission will be in a museum for generations to admire and appreciate. He's a proponent of museum-based education and has discussed how museums inspire youngsters to pursue aerospace careers. A highly experienced naval aviator, fighter pilot, and space traveler with 3 shuttle missions, 2 of which he commanded, and 40 days in space, please welcome Captain Christopher J. Ferguson, United States Navy retired, and crew and commander of STS-135. Okay, it's all yours, Paul.
Well, good morning, everybody. And thank you very much, General Daly, for that kind introduction. I'd like to welcome the viewing audience on NASA TV, and also I understand we have a special classroom tuning in from Bristol, England, and we have a special class, I believe, from Peru as well. So welcome, everyone. What we'd like to do is talk a little bit about our mission, but first I'd like to start out with a brief introduction to the crew. To my right is the pilot on the mission. Of course, we have a commander, pilot, and mission specialist. The pilot on this flight was Doug Hurley. This was Doug's second flight. He is an active duty colonel in the Marine Corps. He's got plenty of time flying F-18 aircraft before he joined NASA. He comes from upstate New York, and he's been with us for about 10 years at NASA. So, Doug?
Thanks, Chris. Hello, everyone. We're greatly appreciate you having us here for a little talk. To my right is our mission specialist one, Sandy Magnus. She was responsible for the logistical load that we took up to space station, the MPLM. Big job. It was almost 10,000 pounds of supplies, food, spare parts, and then she was responsible for getting it reloaded to bring back discarded parts and some trash back from the space station. She's a veteran of 3 space flights, including 4.5 months on the International Space Station. She's got a PhD from Georgia Tech, and she's from Belleville, Illinois. Sandy?
Thank you, Doug. We are always happy to talk about space, and hopefully we'll have some fun here today and give you some insights of what's going on in the space station and the frantic pace of our mission. To my right is Mission Specialist 2, Rex Walheim. He's a retired Air Force colonel. Rex's job on the mission was, first of all, he was the flight engineer, so he kept track of the systems with Fergie and Doug during the dynamic phases of flight during ascent and reentry. And on orbit, Rex was our spacewalk expert. We did not have a spacewalk during the mission that we performed, but the station crew, Mike Fossum and Ron Guerin, performed while we were there, and Rex was in charge of making sure that that got planned appropriately and then executed appropriately. And in the meantime, he also turned into science guy and did a lot of the science that we had on the middeck, just payloads that went up and down on the space shuttle.
Well,
Thanks, Sandy, and it is a pleasure to be here. And before I turn it back over to Chris Ferguson, our commander, I wanted to just say a little bit more what he did on our flight. Obviously, he's the commander, so he's in charge and watching over everything we did. But with a small crew of 4, you can't just have one guy looking back and being the overseer. Like sometimes on shuttle missions, that's one of their main jobs. But he had to pitch in and help in the trenches with us. So besides flying the vehicle on launch and landing and doing the rendezvous and docking, he got to help out in robotics and transfer and all sorts of stuff. So he kept us all on the same page. Thanks, Rex.
Before we continue with our presentation, I'd just like to say how nice it is to be here in this fantastic museum here at the Air and Space Museum. I think that I speak for the entire crew when I say that our love, as we were youngsters, as some of you are right now, for things like science, space, aviation, rocketry was all cultivated in wonderful facilities like this. And if some of you youngsters out there are perhaps interested in what you see today and what you see around you in this wonderful facility, you know, there's plenty of opportunities with NASA or perhaps your own home space agencies. And we're always looking for fantastic astronauts who want to enjoy these experiences or perhaps work as one of the mission controllers or work to design one of these fantastic vehicles that fly into space. So with that, why don't we go ahead and go to our first slide, and we'll begin to talk a little bit about our mission for you. We launched on July 8th of this year.
What does it take to just send something into orbit without having any aerodynamics to worry about? You know, we did that throughout the 60s. To send something to orbit and bring it back as an airplane, that's a whole other synthesis of aero and space. And we're reminded how beautiful a word that is, aerospace. 2 fragments that were never brought together before they needed to. And the shuttle is the living example of what it is when aeronautics meets space exploration.
September 1976, more than 4.5 years after President Nixon signed off on its development, America's new spacecraft, Constitution, gets its first close-up before the cameras. The orbiter itself was well received by the public, but impassioned fans of a particular long-canceled television series called Star Trek wanted it called something else. They staged a successful write-in campaign, and the orbiter was renamed for the Starship featured on the show. Thus, NASA's new shuttle would be the Enterprise, boldly going as no spacecraft had ever gone before. Whatever its name, this bird still needed to prove it could fly. August 12, 1977. On a crystal clear California morning, high above the Mojave Desert, 2 NASA test pilots ready for Enterprise's first flight. The plan was for Fred Hayes, Jr. and Gordon Fullerton to lift the orbiter off a modified 747, then land on a dry lake bed 15,000 feet below. Columbia was undergoing preparations for the program's maiden voyage.
STS-1, an unflown vehicle, and those 2 men getting on board and flying that, trusting that the engineering was correct, trusting that the design was correct, trusting that all the safety measures were in place. To me, it's just amazing.
And you just looked at it on the pad and you said, this looks like no other rocket that I've ever seen before. It's got huge boosters, a tank in the middle, and it's got the equivalent of an airliner hanging off the side. And even though today, by today's standards, it's a very common sight, we're used to seeing it, by the early 80s standards, it was completely revolutionary. And to know that it really wasn't going to fly a test flight. It had flown some gliding landings, but it hadn't flown a real test flight. And the first time it was going to fly, it was going to have two people on board, John Young, Bob Crippen. That was a major milestone.
I remember all the talk about the shuttle in the early days, and there was such an excitement in the air because up until then, what were we doing? You know, a capsule would go up and would plunk down in the ocean. You have to go fish it out. And now we were making a space plane. And how awesome is that? You know, it's a rocket when you need it to be a rocket, and then it's an airplane when you need it and want it to be an airplane. And so, what a promise for the future of the space program that represented.
Next slide.
Can we go to the next slide? As I said, we launched on July 8th of this year. Here you can see the crew at what we call rollout. Rollout is when we take the assembled space shuttle from the vehicle assembly building and we take it out to the launch pad. Normally occurs about a month before launch. And this was a grand affair. You can see that they had the large xenon lights that were focused on the space shuttle as it rolled out. It was really quite an amazing experience. It was the first time I had ever attended, and I was disappointed I hadn't gone to a few others. Because it really is, it reminds you of just what an incredibly gorgeous vehicle this is. It looks, I mean, you can see it, it looks like an airplane strapped to the side of a rocket, and it flew like that for 30 years, and it served us so very well. You also notice there's only 4 crew members on this flight, and that's very unusual. Typically we fly with anywhere from 6 to 7 crew members. The reason we had 4 crew members on this flight was because it was originally manifested as a rescue mission. We were going to serve just in case the STS-134 crew was stranded aboard the International Space Station. And we have done this ever since we lost Columbia back in 2003. We've provided for a rescue mission to go get a space shuttle crew that perhaps got stranded. Now, of course, we've never used them, but it's always best to be prepared. Well, so we selected a crew of 4 for just that reason, because that's all we needed. And then as evolution came about, we found out we were going to put a payload in this flight just in case we launched. We could resupply the International Space Station with the provisions that they would need to last them about a year. And then as time drew to, as launch got closer, we realized that we could actually fly this mission. And the way we were going to rescue the crew members, because of course there were no space shuttles to come after this, was on Soyuz vehicles. We were going to use a Russian rocket system to bring these crew members back, us, just in case for some reason we got stranded. Now, of course, that didn't come to play, but that's why we had a small crew. It made us very busy on the flight, but one thing we had going for us is we were all experienced. We had all done it before, so there was nobody who was going to experience space for the first time, and we knew we'd be able to get to work right away. Next slide. It was enormously proud to be part of this flight. And show of hands, was anybody at the launch of STS-135? Wow, there's a lot of folks who were there. Well, we included this slide just to show you that you were part of a much larger group of people who came out, and it was encouraging for us. I think it was a true testament to how much the space shuttle had meant to the American public. We had a lot of folks who were associated with the program for over 30 years. We had a lot of people who had never seen a space shuttle launch, and they knew that this was their last opportunity. For those of you who may recognize this is the Titusville Bridge, and they close it during launches, and it was just packed with people. And we have tens of images just like this of crowds of folks who had come to occupy every little viewing spot anywhere around Merritt Island to watch the final space shuttle flight. Next. Launched on July 8th. The mission was scheduled to be just slightly less than 12 days. We ended up getting a 1-day extension. That took our landing time, just that 1-day delay took our landing time from a dawn landing, from a daylit landing to a night landing at about 5:30 a.m. It ended up being just short of a 13-day mission. One thing unique about Atlantis is it does not have a power system that we can plug into the space station like the other 2 space shuttles, Discovery and Endeavour, had. Discovery and Endeavour could fly 16-day missions, basically using power from the International Space Station. Atlantis didn't have that, so that's why we kept it to a smaller, shorter mission. We have a wonderful video that shows the launch sequence. We can go ahead and run that now, and then we'll come back and hear from Doug.
When a generation accomplishes a great thing, it's got a right to stand back and for just a moment admire and take pride in its work.
Okay, Fergie, we're starting to feel pretty good down here on the ground about this one today. So on behalf of the greatest team in the world, good luck to you and your crew on the final flight of this true American icon. And so for the final time, Fergie, Doug, Sandy, and Rex, good luck, Godspeed, and have a little fun up there.
Hey, thanks to you and your team, Mike. Until the very end, you all made it look easy. The shuttle's always going to chapter of a journey that will never end. You and the thousands of men and women who gave their hearts, souls, and their lives for the cause of exploration have rewritten history. Let's light this fire one more time, Mike, and witness this great nation at its best.
Will hold at T-minus 31 seconds due to a failure. NNTDSP. Go ahead. Yes, sir. We need that to go do the verification per the LCC, please.
CMAC, the LCC says we need to verify using a camera.
Okay. Let us know as soon as 62 is flown over and you can verify LCC for GDA retract, please.
It's a CMAC. We verify retracted.
All right. And FTE? And NNTD, FTE concurs. They satisfy the requirements of GSC 13 pre-plan contingency. I am go.
Yes, sir. I heard all that. Concur. Press on.
Atlanta station on the big loop, we have you in sight. Excellent, we'll be there soon. We're waiting. Houston station, Atlantis on the big loop, initiating RPM in 3, 2, 1, mark. Atlantis, Aladdin. Welcome to the International Space Station for the last time. All the checks look good. Are you guys ready?
Ready, you ready to rock and roll? Ready to rock and roll. Let's go, buddy.
Very nicely done, Ron.
Nice looking spaceship you guys got here.
Why, thank you. 7, 6, 5. Good work, Mike.
This is fun. Fixing stuff.
All right, Mike says Eagle Scout, are you ready to get your origami merit badge?
Thank you to Ron and Mike and Rex for executing a great EVA to close this all out as the last of the shuttle EVAs. Really appreciate that.
Okay, so for all you guys who've worked at Expedition 18, I'd like to announce the return of the SARS.
Okay, Mike, I was commenting you probably have a future in closet organization.
Hey, that's the great thing about space flight. You know, one day you're doing the most outrageous thing humans have ever done, spacewalking. The next day you're fixing toilets and packing boxes.
Good evening, Sandy. Go ahead for transfer.
Okay, per all these call downs, I show everything complete in the MPLM, and it's actually chock full.
Atlantis departing the International Space Station for the last time.
40 seconds, Columbia now 39 nautical miles to altitude, 42 nautical miles down range. Columbia, you're looking a little hot, and all your calls will be a little early. The younger trip is really moving out now, watching now, reading 6,200 feet per second.
Mission complete, Houston. After serving the world for over 30 years, the space shuttle's earned its place in history and it's come to a final stop.
And you can go to the next slide, please. So this is the picture of the MPLM, which is the cargo vehicle that you saw supplying, using the robot arm to attach to the station. And this is where all of the 10,000 pounds of cargo was packed that we had to transfer over to the station. So inside each one of those white bags is food and supplies and spare parts and consumables. And there were also bags on the back side of those racks. So it was really kind of hectic for the whole time that we were docked, keeping track of what was coming over the hatch and going to station and coming back from the station to come back to Earth. But we got it all done, and even though it was pretty busy. Go ahead and go to the next slide. Of course, when we got to the space station, there were 6 crew up there living already, 3 Russians, Japanese, 2 Americans, and it's always great to dock to the space station. If you can imagine something the size of a football field on orbit, that's what the space station is. And they've been living there from 3 to 4 months already, and they were very helpful in the mission. We made time in the evenings to get together and have dinner. We just intentionally stopped work. We had dinner back in the service module. This is a picture back in the Russian segment where their galley is. There's a galley in the middle of the station in Node 1. We had dinner there one night, and then we invited them over to the shuttle one night as well. So it was kind of fun to get together and just relax at the end of the day. Next slide.
Yeah, one of the important parts of the mission was the spacewalk, and we did that using the space station crew. So Ron and Mike went out and did about a 6.5-hour spacewalk. Their main task was to bring back a pump module that had failed on the space station. So we utilized the space shuttle. One of the big advantages of the space shuttle is that it has a heavy lift capability, but also a capability to bring back a lot of cargo. And so we had the spacewalkers bring this pump module back to the space station's cargo bay, and they were riding on the robotic arm that Doug and Sandy were driving. Brought it back so we could bring it home to find out why it failed, because this was a big failure on the space station. We really needed to know what was causing that. And we also put a new experiment outside the space station called the Robotics Refueling Module, or RRM. This little module was put out in the space station, and it's going to be used to test ways of robotically servicing satellites, and servicing satellites that maybe weren't even built to be serviced. So it has a bunch of different tools on it that you can use to practice grabbing satellites and opening caps and maybe even refueling them, cutting safety wires, lots of different activities. So we'll learn a lot about how to service a satellite with that. And then we brought them back in after 6.5 hours. You can imagine it's a long day, but it takes almost the whole crew to get something like that pulled off. So next slide. You also have to look out the window when you're in space. That's one of the most fun things to do. And here's a beautiful picture of, I believe that's the DC area there in space. And it's just absolutely spectacular at nighttime. It's just an amazing sight to see the places you've been to, the places you want to travel to, your hometowns. And nighttime and daytime both are absolutely spectacular. Now, one of the most spectacular things you see are the northern and southern lights if they're active. And we were very fortunate that the southern lights were very active when we were up there, so the Aurora Australis, and we had a chance to see that and take some pictures of it. And actually, after we left, it even got a little bit brighter, and Mike Fossum on board the space station, he had a chance to take some pictures that were stitched together in a video, and we'll go ahead and on the next slide, you'll get a chance to see that. So you can see the solar arrays going by there, and there's the aurora, just spectacular. The beautiful greens below, and then the higher energy red aurora that actually go up from the Earth, and they almost come up to your altitude of about 200 miles. Spectacular sight. Next slide.
Okay, this picture, you can see it looks like a typical crew picture on board Atlantis, but what I want you to notice is the American flag between Rex and Sandy. It's a very special American flag. It flew on STS-1, the first shuttle mission, And a few days before the mission, they came up to us and asked us if we would like to take it and leave it on board the space station. And of course we agreed, and prior to getting to the space station, we kind of hung it on the flight deck, and it just meant a lot to us serving the country and the way the shuttle has served the country for over 30 years. And it was very special to us, and we wanted to capture this picture here. What we did with that flag is we left it on board the space station in the hopes that the next U.S. rocket, that crew takes that flag and brings it back, and then ultimately it goes beyond low Earth orbit out to the moon again, or Mars, or wherever we decide to go as a destination. Next slide. This is a neat picture. I don't know if you guys noticed in the video, towards the end, you saw this mini satellite being launched from our payload bay. And we didn't know this at the time, but that mini satellite had a number of cameras on board. And the neat thing about this picture is obviously it was taken by that PicoSat, is what the name of it was. But this is the last picture of a space shuttle on orbit that we'll ever have. And we thought it was just a really neat picture and wanted to show it to you. Next slide. Okay, this is the pre-dawn hours of July 21st. About an hour prior to this, we fired the orbital maneuvering engines over the Indian Ocean, and we covered that 4,000 miles and change in just a little over an hour, and landed at Kennedy Space Center. Sun came up as we were sitting there waiting, as folks were coming up to the orbiter, and then we got to spend some time with those wonderful folks down at Kennedy Space Center who had worked on the space shuttle for so many years, and it was really great to share some memories of the flight with them and thank them for everything that they've done, and just been a wonderful program. Next slide.
The Hubble telescope. But that alone doesn't do justice to all the other satellites that were launched, deployed, repaired, retrieved. And so this is the kind of access to space that I think we all fully expected to happen. And in fact, it did.
Next slide, please. Yeah, and as being a part of the last crew, of course, we couldn't help but sit down and think about what the shuttle program has given the country. And there's such a wide variety of missions that it ended up doing, some not even envisioned when the shuttle was built. You know, for example, there were independent science missions. The shuttle flew, launched, and just stayed in low Earth orbit, orbiting the Earth the whole time, 10, 11, 12 days, carrying out missions in the life sciences, the physical sciences, radar mapping, Earth observations, missions where we launched telescopes, we launched satellites, we serviced the Hubble telescope 5 times. It's given so much just as an entity in and of itself in its low Earth orbit operations. And if you go to the next slide, please, you'll see what we consider sort of the crowning jewel of the space shuttle and its legacy to our country and the world, because this was certainly something that wasn't envisioned for the space shuttle when we first built it, was that it would be participating in and integral to the building of a space station. 37 flights, that a third of the flights really of the whole program, slightly more, that the shuttle performed to carry piece by piece of this amazing space station up there. And if you can imagine that picture, as I mentioned before, from end to end, it's about the size of a football field in both directions. It's a little bit skinnier as you go down the living quarters, but it's incredible when you go rendezvous with this space station and see how large it is, this laboratory, this home. We've had people living on for the last 11 years, people from all over the world. And I think we all agree it'll be one of the strongest legacies of the Space Shuttle program. And go ahead and go to the next slide, please.
My mental image is that, you know, NASA should be doing those things that are on the leading edge. And the shuttle has been an amazing learning tool to provide us the platform and opportunity to learn how to operate in low Earth orbit. We've learned how to assemble, we've learned how to do spacewalks, we've learned how to control the medical aspects of spaceflight, especially long-term spaceflight. We've learned a lot about just how to do things in space. We got Hubble in extremely good shape, we've got ISS in extremely good shape. Now we have other areas coming up to take over the LEO functions that the shuttle did. And what we're doing is we're sacrificing the shuttle to enable us to be able to take that next step. if we were going to retire the shuttle, this is the time to do it. And I think that we're going to just expand the breadth of things that we do as a nation and as an international partner.
In just a moment, we'll go ahead and take some questions. I'm sure you probably have some on what it's like to live in space, but just let me just again speak on behalf of the entire crew. You know, this was the last time that we were up there on a shuttle. We were extraordinarily busy, as I said, due to the reduced crew. But the night before landing, we did have an opportunity. We slowed down, we finished everything that was on our timeline to just look out the window and reflect a little bit on what it meant to us. And from a personal standpoint, you know, I found it extraordinarily difficult to believe that this was the last night that a space shuttle was actually going to be on orbit. And a part of it made me sad, but a part of it made me extraordinarily proud to be part of the program. And however you feel about where the space program is headed, of course we're going to take some time off and we're going to use the money that we had been using to operate the space shuttle to develop a new system to take us back to low Earth orbit and to take us beyond low Earth orbit. There is no denying that the space shuttle in its 30-year history will be looked back as one of the true revolutionary spacecraft, and how lucky and fortunate we truly were to have had it. That this nation has the tremendous dedication to put forth the resources to building something like this, and then has the stick-to-itness and the devotion to stay with it for the 30-year period, and to look back and see what it's accomplished over its lifetime. Chandra, Galileo, Magellan, the Hubble Space Telescope, we are all extraordinarily proud to have played a small role in it, and you as taxpaying Americans should be extraordinarily proud of the support that you gave the shuttle program as we all look back in just basically wide-eyed wonder about what a fantastic vehicle it was. So with that, I'd like to conclude, and I would also like to, I'm sure some of you young men and women have a question or two about what it's like to live in space, and perhaps some of you older men and women have some questions about where you think we're headed from here. I know I do. We'll be happy to give you our personal insights and where we think we're headed and what we thought about the space shuttle, if you'll so kindly ask. And I'm not sure if there's any microphones for the crowd. Okay, here we go. Thank you.
I just wanted to ask sort of for the kids, and I know a lot of kids, you talk to children, they say, I want to be an astronaut. And so, you know, you probably maybe did that one time when you were a kid. And what I was saying is the kids sometimes, they don't understand the future, and they say, well, how can I be an astronaut? The shuttle's over. So if a kid was thinking like that, what would you say to them?
Well, first of all, the shuttle program is only part of what we're doing in space these days. I had the opportunity to live on the International Space Station for 4.5 months, and we're still flying people to the International Space Station. We're using the Russian Soyuz rockets right now. We have, 16 or so people in training right now for the International Space Station missions where you get to live for 6 months. So believe it or not, we're short astronauts a little bit right now. We need astronauts. And I would encourage any young person in this room or listening to our speech today to come join us at NASA, either in the role of an astronaut or as one of our scientists or engineers or designers or flight directors or flight controllers, because we're going to need you. We have some challenging years ahead. We're going to be starting a new program with a vehicle that will be going out of low Earth orbit, and there's certainly opportunity there. I think some of you young people have a chance to go to the moon or Mars or an asteroid or somewhere out of low Earth orbit, and I think that would be a very exciting destination indeed. So clearly there are options, there are jobs, there are opportunities at NASA, and we want you to come join us. Anybody else have any questions? If you wouldn't mind maybe coming up to the microphone when you have a question, and that way everyone will be able to hear it. Yes, sir.
How does Earth go around the sun? How does the Earth go around the sun?
How does the Earth go around the sun? Would you like that? Rex?
Yeah,
Well, in the beginning.
Yeah.
Well,
just the Earth goes around the sun because the Earth has a velocity, and it goes around, and the gravitational pull of the sun is what keeps the Earth in its orbit. If the gravity of the sun didn't hold on to the Earth would go swinging out past the outside the solar system. So it's the gravity of the sun that keeps the Earth orbiting around it.
Thank you.
Thank you.
Good job, Rex.
I know there's been a lot of talk about returning to a capsule-based vehicle as opposed to a aircraft-type spacecraft. Do you think that's the future of manned spaceflight? Why or why not?
All right, I'll take a swing at that one. Yes, if you had to look at any one of the number of replacements that are out there for the space shuttle to get humans back and forth to low Earth orbit, a lot of them are capsule-based. The one that NASA has been working on for years is called the Orion, which is a capsule. And that will return to Earth, like you said, under a parachute, and it will land on the land using airbags to cushion its final landing. Now, there are also other systems out there. Some of our commercial partners who are all vying for this business to get astronauts back to low Earth orbit again. One of them is a company called Sierra Nevada, and they're building an aerodynamic vehicle that will return not unlike the shuttle does right now, to land on a runway. Which direction we go in ultimately, I'm not sure. We're going to have to wait and let them demonstrate their capabilities to us, and ultimately we'll see which is best for the country. Now, the vehicle that will ultimately go beyond low Earth orbit will likely be the Orion capsule, and that will return to Earth in, as you said, under a parachute in a capsule type of reentry. Now, some would say that capsule is kind of taking a step backwards, back to the Apollo days. I would contend that a capsule is probably, when you're coming back from those interplanetary velocities, when you re-enter the atmosphere at something larger than we normally orbit the Earth at about 25 times the speed of sound, when you're returning back from an interplanetary destination, the moon, an asteroid, Mars, you're going to be coming back a lot faster, Mach 28. And just that extra energy it's very difficult for the modern day materials to handle that. And it would be very difficult for an aerodynamic vehicle to fly back from a lunar or an asteroid destination and take all that energy out. So you're better off with an ablative heat shield, which is what you see on the bottom of these capsules. So a capsule is actually a safer way to come back, especially from a destination that's beyond low Earth orbit. So they each have their balances. Does anybody else want to add anything to that? No? Okay.
Well, thank you very much.
Sure thing.
What's NASA going to do now?
What's NASA going to do now?
It's always the hard questions from the youngest individuals.
Yeah. No, that's a good question. We've got a couple things that we're working on right now. The first thing is we've got to get another way to get to low Earth orbit. In other words, back to the space station since we retired the shuttle. So we've got commercial companies. There's 4 commercial companies working on designs for vehicles that will take astronauts back and forth to the International Space Station. They expect to be ready. One or more of those companies expect to be ready to take astronauts to and from the space station in the 2015 timeframe. To go beyond low Earth orbit, in other words, to go outside Earth's orbit to the moon, asteroid, Mars destinations, we're building what they call SLS, the Space Launch System. That was just announced a few weeks ago. And that's a large rocket, over 400 feet tall, so huge rocket. On top of that rocket would be the Orion MPCV, the Orion capsule. And there's a plan to have an unmanned mission as early as 2017, and then a manned mission a little bit beyond 2020. So probably right about the time you're ready to be an astronaut, you'll have a ride to maybe the moon or an asteroid. So that's our plan. So we've got kind of 2 different things going on, working in parallel, and a lot of great things to come.
Yeah, and just to add to that, in the rover or the unmanned program, we have a launch the day after Thanksgiving of a new Mars rover. It's about the size of a VW. It's a very, very large rover, and we're going to send it to Mars. It's going to get there next August and start roaming around on Mars and giving us more information about what Mars is like. So that's going to be very exciting too. You remember the Spirit and the Opportunity rovers? They were tiny, maybe about this big, and this one's going to be the size of a small car. So we're going to learn a lot about Mars when it gets there next fall. So that's pretty exciting too.
And Go ahead. Thank you very much. We'll take the next question, but I just wanted to make sure that, because I don't think we brought this up, in this interim period that we're waiting for the United States to come up with another vehicle to get us back to low Earth orbit, we're depending on our Russian partners. Of course, they've successfully flown the Soyuz spacecraft for decades now, and they are our primary way back and forth to the International Space Station. So when American astronauts are ready to go, like Dan Burbank will be the next one to launch to the space station. He's over in Russia right now, so he's preparing to go down to Kazakhstan and launch on November 14th is the current launch date. So we're depending on them until we're ready, probably 5-6 years from now. Yes, ma'am.
After being on the space station for 6 months or so, how does one readjust to coming back to Earth?
You know, that was something I was sort of curious to find out about as well. And one thing that you have to do if you stay in space for any long period of time, actually any time after 2 weeks, is you have to exercise 2 hours a day. It's very, very important. We have exercise equipment up there, a treadmill. You kind of bungee yourself to the treadmill and it holds you down and you run, and that's good exercise to get that pounding on your heels and your hips and your lower legs and thighs. And then we have a bicycle ergometer. You can bungee yourself down to that and do cardio and get your heart working really well. But most importantly, we have a resistive exercise device, and it simulates weightlifting. You work against a vacuum, some vacuum cylinders, and you do things like squats and deadlifts and some of these exercises to really activate the legs muscles and your back muscles and things like that. So if you exercise for 2 hours a day the way you're supposed to, you can come back strong. For example, I was able to walk, I was able to stand up, I was able to work against gravity. It wasn't pinning me to the floor like I was a pancake, which is what it's trying to do to all of you right now, and you don't realize it. Gravity is just overwhelming force. It's just you are working against all the time, and that was interesting to feel that. But my balance was off. You have to be careful when you get back from space for a long period of time, because you approach a corner and a quarter, and you go to turn the corner, and maybe you're not good at judging when to start turning, and you hit the wall. So people are following you around for a few days to make sure that you're okay. You don't want to move your head around like this really quickly. If I wanted to look that way, I moved my whole upper body because my inner ear, my vestibular system was all messed up, and that took about a week. And then after about 2 weeks, I actually had enough energy to operate in gravity. For about 2 weeks, about 5 o'clock in the afternoon, I just wanted to lay down. I was so tired because getting used to doing all of this motion and gravity wore me out. But our rehab program is 6 weeks long, and after that, I felt fine. Really, after about 3 weeks, I was in pretty good shape. But you have to exercise 2 hours a day.
Thank you.
Mm-hmm. Do you have a question for me?
Hi. Maybe typical is a hard word to use about living in space, but what does a typical day look like at living in the space station?
On space station?
Yeah.
Well, space station, it's between a shuttle mission and a station mission. It's a difference between a sprint and a marathon. For example, we were very busy during the space shuttle mission because we had a lot to do and we were only going to be there for a short period of time. And so our timeline was very, very packed. On space station, it's a little bit more leisurely because you're going to be there next week and the week after that. So you get up in the morning, you have a planning conference with the ground and you talk about what's going to happen that day. They have tasks scheduled for you throughout the day, whether it's science experiments or public appearances via video or maintenance. You have to fix something that broke. You've got exercise scheduled. So you talk about that. Then you start working on your schedule, what they've scheduled for you. You break for lunch. Somewhere in there you exercise. At the end of the day, when you're done with all your tasks, you have another planning conference where you go over what happened during the day. If there's been any problems or there's any adjustments to tomorrow's schedule, you talk about it. Then you have time to relax. And this is what you don't have during a shuttle mission, because you're busy all the time. But you have dinner, and then you've got a few hours, just like when you come home from work or school, you do your homework, and then you have time to relax. You can go look out the window, you can watch a movie, you can call your family. When we have the right antenna signals, you can talk to your family, you read your email, you look out the window some more, take some pictures, and this is sort of a typical day.
Did you have a dream of being an astronaut when you were actually a kid?
Yeah, I think a lot of us did have dreams of being an astronaut when we were a kid. Like when I was in your age, I loved drawing pictures of airplanes and reading books about space, and that was one of my interests. And I didn't think it was really a possibility until I got older, but I did work really hard in school, especially in science and math, and tried to get as best grades as I could. And then as I got older, I realized, okay, well, I ought to try to take this seriously. And so I took the jobs that I thought would prepare me. And I applied a couple times, and the first time I didn't get accepted. And that happens a lot when you're trying for a really high goal, is that sometimes you just don't, it doesn't work out the first time. So the important thing is to keep trying and trying again. So at your age, the best thing is to work really hard in school, because that's going to prepare you for any kind of career. And maybe you'll get to fly in space too. Thanks.
I noticed that young man from Bristol who keeps having his, he has his hand up. Can we take a question from there, or?
What's the food like in space?
Okay, I'm just going to repeat that to make sure I understand it. Did you ask what is the food like in space?
Yes.
All right, I think everybody has their own opinion of the food in space. And first, let me caveat, I'll give you my opinion, but I'm probably a bad judge because I spent 26 years in the Navy and I like Navy food, so my standards are pretty low. The food we have in space is not unlike meals ready to eat, some of them. Thermostabilized packages of food that are very good. Gone are the days where we would squeeze our food out of a toothpaste tube. We have wonderful things like seafood gumbo and crawfish etouffee and chicken fiesta. I mean, we have wonderful dishes, and they're the thermostabilized ones. We also have rehydratable foods. We like rehydratable foods because they're lightweight to carry into space, and we add water. And the interesting thing about the space shuttle is it made its own water inside a fuel cell. And we liked to make our water and then use our water, and as a byproduct of that we got electricity out of our fuel cell, so it was a really nice system. So we used a lot of rehydratable food too, and that was not unlike some of the containers you might see where you squeeze some water in and you just let it sit for a while and it actually comes to life again, and it's really good food. And then we have some traditional fresh food that you might have, not a whole lot, like apples or crackers, or peanut butter is a very favorite food in space. And I call it the ultimate food glue, because peanut butter is good because things float away, and when food floats away, that's bad. But peanut butter keeps everything in one place so you can pop it in your mouth. So peanut butter is the perfect space food. Thank you.
What was your favorite thing about being in space?
It's a really hard question because there's so many different things. Floating and flying around in the modules in the space station is an unbelievable amount of fun. The other thing is looking out the window, because you can go around the Earth in 90 minutes. You can see the whole Earth in 90 minutes. So it's just amazing. And you know, the daytime views going over to the United States, trying to pick out where you were from or where you live now, and then the nighttime seeing thunderstorms and southern lights, just incredible. So there's a lot of things that are great about flying in space.
Thank you.
Thank you.
Are you ever going to the moon again?
Well, I sure hope we are. I think that'll be one of the destinations. Our next program is twofold. There's two ways we're going. Number one is to get to low Earth orbit. The space station is close to the Earth. You know, the moon is far away from Earth. So our second program is to do more exploration, to get beyond the Earth, and to go places like the moon, an asteroid, or Mars. Now the question is, where do you go first? And so as we build this new rocket, we're going to be able to go to any of those locations over time. It just takes time. The hardest one is to go to Mars. It's the farthest away, and there's a lot of challenges to go to Mars. But other ones, like maybe an asteroid or maybe going back to the moon to try out your new system. But I'm sure we'll end up back there someday. I'm just not sure what order we'll go there in.
One of the interesting things, and that's okay, you can go and sit down. One of the interesting things about the space station is that we have systems on there that are doing things like recycling our air and our water that are fairly new technology. I mean, who would have thought 5 years ago that we'd be willing to take all of the liquid aboard the space station that we produce as waste, whether it's urine or condensate from an air conditioner, and reuse that and drink it. But that's really what you have to do when you go on these long trips, because water is extremely difficult to get to space, not to mention it's very heavy. And we're perfecting these kind of systems on the International Space Station Because when we go to Mars someday, or we go to a destination that's far away, the water recycler, the air recycler is going to have to work, because if it doesn't work, the astronauts will die. So we want these systems to be high quality and redundant. And these are the kind of great things that we're doing in orbit on the space station today.
I was wondering a detail about your mission concerning who is going to actually land the last spacecraft that really has wings. So did you go up to Doug and say, well, you're the pilot, but I'm the commander, so I'm going to do it?
No, we never even had that discussion. It's generally the left seater that will land.
Commander.
The commander, who's the left seater, and the pilot will back him up. But like any airliner, we always carry some form of redundancy just in case. And you know, the interesting thing is, I'll let you in a little secret. When we were up on the space station, I got kind of conked in the eye by a bungee cord of all things. It just kind of sprung loose and it hit me in the eye, and I was fine. You know, I had a little scratch and there was a little bit of blood, which is another whole story, how blood flows in space. But you know, I think that both Doug and I were thinking at that moment, gosh, you know, here's the guy who's supposed to land the space shuttle, and he almost hurt his eye. What would they do? And you look back, we've never had the pilot land, but the pilot is just as trained as the commander. And if there ever was an opportunity or a reason for the pilot, the right seater, to land, he's every bit as qualified, and I'm sure Doug would have done an absolutely fantastic job. A lot of people probably wonder if Doug didn't have a bungee in his hand before my eye got hurt. But we have redundancy, just like we do in a lot of systems in space, just in case.
How plausible is it that we can build another space station on top of the moon?
On the surface of the moon, or on orbit around the moon?
On the moon.
Well, that's one of the things that's being debated, of course. If we go back to the moon, do we go back to the moon just to do technology demonstration and development? For example, one thing we don't have to deal with these systems that Chris was talking about we're testing on space station is the dust. You know, they had a problem with that during the Apollo, is all of the dust on the moon, it's very fine, it got into the spacesuits, it can get into small crevices and be a problem. So do we go back to the moon and we just do technology development and make sure we understand the environment before we go further, or do we establish a base there, which is I think what you're talking about, and actually put people there and live there? In the previous program, the Constellation program, the plan was to actually go there and establish a base there and build up a wealth of experience living in an environment like that. And now that's a little bit more under debate. So I really don't know what we're going to do. It's funny, some people have this attitude that, oh, we've been to the moon, we don't need to go back there again. But we really just barely scratched the surface of what the moon is and our understanding of it. So I think there are things we could certainly learn if we went there. But I don't know if we will or not. We'll have to see. I think we'll go at least to do technology demonstration, though.
Thank you.
Hi, I'm Tay on Twitter, and thank you, Sandy, for responding back on this visit here. My question is, what are you all's your goals when you're finished here? Are you going to teach, perhaps, or are you going to continue working on your astronaut careers?
Well, you know, we're still trying to figure that out. We landed on July 21st, and really since then we have been busy doing this kind of work because it's important to talk to people about our experiences and share our experiences. And we have about another month of this, and then we sort of go back into normal life mode. And I think at that point we'll start, having a chance to think about what comes next. A few of us have the opportunity to fly again on a long duration mission if we so choose. And I don't think we have the answer to that question yet.
You consider teaching?
Oh, thank you.
I think Sandy's probably considered it. I've considered it. I would enjoy teaching and giving back a little bit. It's the question of, have you given everything you can to the space program, and are you ready to go do that yet?
A question about re-entry. I was just curious, when you're re-entering, and I've seen movies of the heat that's generated on the heat shields and everything, do you all still, in the floor of the aircraft, have a sense of heat coming through it? If you could describe that. And then my second question, if I could, will you all be continuing a tour? I mean, I was just passing through town, and my daughter would love to have participated in something like this. I was curious if you're going to be continuing with a tour. Thank you.
Yeah, for re-entry, the night before, we cold soak the orbiter. So we try to get it as cold as we can, and That wasn't a big thrill for Sandy and I, since we're the ones that always wear long sleeve shirts on orbit to start with. So you got to kind of get dressed up for winter vacation there when you go to bed the night before entry. And so that helps with the avionics and all the, the black boxes. Do you really feel it get warmer in the orbiter during reentry? No. The difference, this was my second flight, and the difference with this flight compared to my first is we re-entered at night, almost the whole way. We got a little bit of dawn just before we came down to land on the East Coast, but it was pretty much predominantly a night entry, and it was incredible, the plasma that we saw, and you saw a little bit of that in the video, but it was unbelievable until we got down to 150,000 feet, and it was one of those things where it's kind of like flying through clouds. We were flying through this pink-orange plasma, and then all of a sudden it was gone. And then you could see the coast of Florida, and we came in for entry. So you do get a sense that you are literally a meteorite re-entering, and there's a lot of heat outside, upwards of 3,000 degrees on parts of the orbiter. But it doesn't really get warm there until you're back on the ground in Florida and the vehicle's been sitting there a while, and then you start to feel a little warmer, although it wasn't anything. But I think it's because we cold soak, that really helps the internal temperature of the vehicle when we're coming back in. And then the other part of your question was, are we going to continue this tour? Yes, as Sandy said, we've got about another month or so, and then there'll probably be individual hometown type events after that we'll go to as well. So yeah, we have a few more weeks to go. Thank you.
One of the things we do is we get out and touch the orbiter after landing, and it's still warm. It's kind of neat. Good thing it's not warm inside, but it's warm outside.
Do you want to get the grill?
You want to go to England one more time?
Let's let this young lady.
Okay.
I think we're.
What's the moon like?
What's the moon like?
What's the moon like?
It's dusty. It's dusty. Actually, well, here we'll talk just a little bit about the moon. Its gravity is about 1/6 of that on Earth. So if you weigh 60 pounds on Earth, you'll weigh about 10 pounds on the moon, which is kind of a neat effect. It allows you to bounce across the surface. The surface is very dusty, and that is one thing you heard Sandy talk about. We have to contend with is that fine dust that seems to get into a lot of machinery. But we think that we know there's a lot of ice crystals on the moon, and perhaps some unique elements that we don't find very easily here on Earth. And they may provide an interesting source of material that we could use to make rocket fuel. So the moon has a lot of potential. It's an interesting environment. And the nice thing is it's right next door. It's only 250,000 miles away, which is pretty close in a galactic sense. I think, was that time for our last question? Yeah, okay. We're going to wrap it up. Okay. I would like to thank everybody for coming out and listening to our story. As I said, this is one of the great foundations for cultivating the interest in young men and women, and for us older folks who have had an opportunity perhaps to fly some of these vehicles. It's really special to be here. Thank you very much on behalf of the crew, and enjoy the rest of your day here at the Air and Space Museum.